Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Copycat Chaos by Andrew Sarkis. And here are the rules. We have chaos construction rules, where we need to divide the grid into 9 orthogonally connected regions and place the digits 1 through 9 once each in every row, column, and region. So what is an orthogonally connected region? It means you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because you can go from any cell in that region to any other cell in that region just by going through edges while staying within the region. Here is an example of an invalid region, because while these two cells can go to each other, I should say, by just going through edges while staying within the region, they can't go to any of the other cells in the region by doing so. They either have to go through a corner or go through an edge and exit the region, which is not allowed. So that's an example of how orthogonally connected regions work. We have copycat cells, where one cell in each row, column, and region is a copycat cell. And each copycat cell contains a different digit. The value of a copycat cell is the digit in the cell, rotationally opposite from it in the grid. So in each row, column, and region, we have one copycat cell. And each copycat cell contains a different digit. In other words, you can't have repeats in the copycat cells. And the value of the copycat cell is the digit in the cell rotationally opposite from it in the grid. So, for example, if we had, say, a copycat cell in row 2, column 4, the value of that cell would be the digit that is in row 8, column 6, right? Because that's rotationally opposite of row 2, column 4, around the central cell in this grid. So say this was like a 6, then the value of this cell, since this was a copycat cell, would be a 6. And that's how copycat cells work. We have numbered rooms, where numerical clues outside the grid are numbered rooms clues. And the clue indicates the value of the nth cell from the clue from that side of the board, where n is the value of the closest cell. In this puzzle, the first n cells belong to the same region. And if n is less than 9, the cell in position n plus 1 from the clue must belong to a different region. So, what's an example of that? So say we had like a 5 here. Then the value of the 5th cell from the clue, from that side of the board, 5 is probably not the best. Let's say 6. Say we had 6 here. The value of the 6th cell in this row, going from this position, must be a 1 in value. So again, it could be a copycat, or it could be copying something there. Or it could just be a 1 by itself. We don't know. And for the first 6 cells, they must all belong to the same region. And then the 6 plus 1 cell, which is the 7th cell, must belong to a different region. So we could have something like this. And that's how these numbered rooms clues works. We have numbered copycats, where cats outside of the grid indicate that the nth cell from the clue is a copycat cell. where n is the value of the closest cell. Oh, that's interesting. N is the value of the closest cell. So if this, say we had a copycat, ooh, that's interesting. If we had a copycat cell here, then the value, this is saying that the copycat cell would have to be in the first position, right? Because the copycat cell is in the first position in this column. Therefore, the value of the rotationally opposite cell would have to be 1. Because for the copycat cell here, n is the value of the closest cell, and n indicates where the that in the nth cell, which would be the first cell, the clue is a copycat cell. And remember, we have 1 copycat cell per row per column, so that helps there. Also, if n is less than 9, the cell in the n plus first position must be in a different region than the copycat cell in position n. However, unlike the numbered rooms clues, there may be any number of region borders between the clue and the copycat cell. So let's give a more concrete example. So say we had, again, a 6 here. That would mean that at first that the copycat cell is in the 6th position. And the 6, if n is less than 9, which 6 is, then the cell in the 6 plus 1 position must be a different region than the copycat cell in position n. So this would have to be a different region here. So that's how numbered copycats, an example of how it works. Okay. We have paw prints, where cells containing paw prints indicate the minimum number of steps along a path required to reach the copycat cell in its own region, traveling orthogonally while staying entirely within the region. And all possible paw prints are given. So say this was a 3. That means 3 away would have to be, by traveling orthogonally, would have to be where the copycat cell is. So we could have, you cannot go 3 this way, so it would be 1, 2, 3 going that way. So this would be the copycat cell. And then this is a paw print too. To get to the copycat cell here, it'd be 1, 2, 3, 4, 5 steps. So then this would have to be 5 if that were the case. And all possible paw prints are given, so there is a negative constraint in place. So that means, say these were the same region, then they could not have, oh, well, let's look at this. These digits could not be 1, assuming that this region was valid, because they are 1 away from the copycat cell and there's no paw prints in them. So therefore, they cannot be 1, because if there was a 1 there, that would mean that it would be 1 away from the copycat cell and would necessarily have to have a paw print, because all paw prints are given. So keep that in mind for the negative constraint there. We have circles, where, okay, so paw prints don't use values. Paw prints is specifically digits. The digits, cells containing paw prints indicate the minimum number of steps along the path. And that's specifically related to the digit, not the value. Oh, well, actually, that makes sense, because the value is going to be the digit, because the paw print is a certain distance away from the copycat cell in its region, right? So the value is the digit for the paw print cells. We have circles, where the value in a circle is the number of cells, including itself, in the surrounding 3x3 neighborhood that belong to the same region as the circled cell. So actually, let's use this as an example. So therefore, this can't be 3. How many cells here are in the same region of the surrounding 3x3 area surrounding this cell? This would be 3, right? You have itself, and these two cells are part of the same region as a circled cell. So this would be 3, which would mean also, since it's a paw print, it'd have to be 3 away from by going through steps from the copycat cell in the region. And also, we have a negative constraint here. All possible circles are given. So, for example, this could not be a 3 because we have 3 cells in the remaining in the 3x3 area surrounding the cell, which are in the same region. This is same with this. This cannot be 5 here because we have 5 cells that are part of the same region, etc., etc. So keep that negative constraint in mind. And finally, we have arrows, where the value of a cell containing one or more arrows is the number of region borders, not including the grid border, seen in each indicated direction. Separately, not cumulatively. So that would mean, for example, that this has to see the value. Okay, let me think that through. Seen in each direction separately, not cumulatively. So cumulatively would mean that all borders would add up to essentially this sum. But here, since it's separately, not cumulatively, that means that's the number of region borders seen in each direction. And all possible arrows are given. So there is a negative constraint for that. So in this case, I guess it would be 1 in each direction. In this specific case, if this were because it can only see 1 in this direction, right? Because we only have 1 border here. Therefore, it must be 1 that way. It must see 1 this way also. So keep that in mind. There is a negative constraint there. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, arrows. Actually, not arrows. Let's start with circles, especially on the edges. This can only have 4 cells in the same region as it, up to 4 cells. And it cannot ever have 1 cell in the 3x3 because you're always going to have to orthogonally connect outward. So you're guaranteed at least 2 cells here in this circle. So 2, 3, or 4. This is 2 through 6 because we could have 6 cells surrounding it. Copycats, unfortunately, don't really tell us much. Arrows. Arrows can be at most... This is guaranteed to see 1 border. So this is a border here. Let's draw borders too. Let's draw borders around the entire grid. So this sees 1 that way. This sees 1 that way. So this is 1 away from... So this is a border here. And this is 1 away from its copycat cell in its region. So one of these 3 is a copycat cell. Okay. This must see more than 1 border. So this is either going to be 2 or 3 because it can see at most 3 borders here. This sees 2 or 1 borders this way. This sees more than these cells here because we see all the borders that this arrow sees, and we must see at least 1 more here because these can't be the same digit. So this is at least 3 up to, what, 6? 1, 2, 3. So 1, 2, 3, 4, 5, 6 borders, potentially. This sees 1 through 4. This can only see 2 that way or 2 that way. At most, so it's 1 or 2. This sees 3 that way. It must be at the most 3 that way. So this is 2 or 3. Cannot be 1 because we can't have 1 there. Also, it sees more boundaries than this. Okay, so this has to be a boundary here because these are distinctly different digits, and they must see different numbers of boundaries then in this direction. So this has to be 3 or 4 at least, or 5. It cannot be 5. It's 3 or 4. This could still be 3. Okay, because it's not counting this. This has to be at least 1 greater than this. So this must be a border this way because these two have to be different digits. So therefore, this must see 1 more digit, 1 more boundary than that. This sees 1 more boundary than that. This can see many more, or at least 1 more boundary than that. So it's at least 4. Up to can see 1, 2, 3, 4, 5, 6, 7. So this could be 4 through 7 there. This sees at most 2 going this way. So this is 1 or 2. This could be, this sees, it could be less. No, it can't be less. So whatever direction that this sees at least 1 more, and this sees at least 1 more than that, and this is a boundary. So this is at least 2 and could be 3. Right? Because it sees, say there are 2 boundaries here. Hold on. Can this be... Can this be 1, 2, and 3? Is that... Sorry, can it be 2, 3, and 4 or more? This sees 1, 2, or 3 boundaries there. This sees 1 through 1, 2, 3, 4, 5. So this could be 5 up to. This is 3 or 4. So only 3 or 4 cells are a part of this region by the 3x3 box. This could be a lot of things. Oh, actually not that many. The number of boundaries it sees this way. So this sees 2 or 3 this way. So we have 2 or 3 in for these boundaries there. You could have 1 more. So this has to be at greater than this. So this must be at least 3. Because it counts the same number of boundaries here, and then we have an extra one here. But it could be 2 more, because this could also be a boundary here between the 1 and the 2, 3. So it's 3, 4, 5 there. This is at most 1, 2, 3, 4, 5, 6, 7 boundaries. It can't be 7, a full 7, because if it's a full 7, then this would be blocked. This would have a boundary on either side, and then would be blocked from orthogonally connecting to a full region. Okay. All possible arrows are given too. That's interesting. Okay, so 1 is here. The numbered rooms clues outside the grid are the clue indicates the value of the nth cell from the clue from that side of the board where n is the value of the closest cell. So either this is going to be... Wait, is arrows numbered rooms clue? Oh, shoot. This is not necessarily 1. These are... Arrows are not our values. Ugh. Okay, so... Oof. Oh, okay, that's going to be painful. We know this value is 1. We know this value is 1. This value must be 1 or 2. Value must be 2 or 3. Value must be 3 or 4. So we know paw prints cannot ever be a copycat cell. So this can't be a copycat cell. Paw prints are never copycat cells. That's interesting. So this is guaranteed to be a 1. And this has a value of 1, but it could be a copycat cell because this is a 1 as a digit. Guaranteed. Okay. But this could be a copycat cell here. This still has to be value 2 or 3. I don't think we made any assumptions based off that, so that's fine, I guess. This has to be value 2 or 3. So the value... So this is guaranteed to be 1 here. We don't know what that is. As the copy... It could be a copycat cell. So numbered rooms. So this has to be value 3, 4, or 5. Definitely. Because this can see at most 5 boundaries this way. So that means value of the closest cell. So one of these has to have a value of 1. Well, it can't be 5. So this cannot be value of 5. It has to be 4 or 3. These values have to be greater. These values have to be greater than this. Okay, so the question is this value. How does that work? So this cannot be copycat either. It would be copycatting that, which has to have a value of 3. It has to be a digit of 3 or 4. So this can't be copycat either. Can we have... Yeah, as I was thinking, can we have... If this is 1 in both directions, that's not going to work. If we have 1 here and then 1 here, then this... We have this one direction, we have this one boundary that we see there. So this can't see more than 1 going this way. Therefore, this can't be 1. This must be 2. This must be 3. and this must see 4. So one of these 2 is a boundary here. And we see 2 boundaries. This is 2 here. So this must see boundary here and here. Interesting. Again, this can't be 7. Now this can't be 6 because this has to exit out one of these ways here or one of these ways here. And if we have 6, we're guaranteed 2 out of 3 of these cells have boundaries, and therefore it's going to be stuck. So this is 2. We have a boundary between here. We don't have a boundary here. So these are guaranteed to be next to each other. We have 2 boundaries that way. But we don't know if these are value. This is not a value. Sorry, it is a value, but it's not a copycat, I should say. These could be copycat cells. So we don't know. Copycat would be there. Copycat would be there. That is possible. This sees 1 through 4, and it's not a copycat. So we have 1, 3, or 4 here. Which means one of the... Okay, so cannot be 3, because then that would be... It would say that that value of the third cell would be 1. Oh, this has to see greater than this. So this is at least going to be 3. So the value of this is never going to be 1. So therefore, this has to be a 1 here. Right? The clue indicates the value of the nth cell. It could only be 1, 3, or 4 here. So this must be 1. The value of the copycat cannot be 3. It could be 2 technically. This is 1 away from the copycat cell. So 1 is saying indicate the nth cell from the clue is the copycat cell. So the first clue in that direction is the not copycat. The clue indicates the value of the nth cell, which is the first cell, where n is the value of the closest cell, which is 1. Right, so that does work. 1, 3, 4. But, so one of these 3 has to be the copycat cell. Because if we don't have a copycat cell in either of these places, we're going to have overlap, right, in digits. So, one of these 2 is a copycat. That means none of these are copycat cells. And this cannot be, this has to have a value of 1 for the copycat cell. And we already have a 1 in the column, so this must be the copycat cell. We'll make it green. So this has a value of 1, which means this cannot be copycat cell. None of these can be copycat cell. Neither can these. So we have 3 and 4 here. Remaining digits in the column are 5 through 9. But this copies the 1 here, which means that's valid. So this sees 1 boundary here and 1 boundary here. We don't know which direction. So, oh, it sees 1 this way and 1 that way. This has to be greater than that, so this must be 2. So this must see 2 boundaries this way. So there's no boundary here. There's 1 going between these 3 and then one of these, because this is value 1. So there's 1 boundary that way, 1 boundary that way. This is 2 then. No boundary here. This is 2 as a digit because it has the paw prints. Remaining digits in column 5 again are 5 through 9. So the copycat cell is 2 away here. So it could be 1, 2, it could be 1, 2. So one of these two is a copycat cell. If this were the copycat cell, the problem is, if this is the copycat cell, this would also have to be a 2 in value, but obviously this is the copycat cell, so therefore that can't be 2 in value for being a copycat, and it can't be a regular 2 because of 2 in the row. So this cannot be where the copycat cell is, so 1, 2 away must be a copycat cell. That eliminates copycat cells in the rest of the row and column. And these are the same region, but we don't know which way it goes. Well, this is 1 away from that copycat cell, so they could be actually the same region. Or this is a copycat cell here, which has the same problem. If this is a copycat cell here, this would have to be a 4 to signify where the copycat cell is. But it can't be 4 because... Right, because the copycat cell would have to be in that row, would be here. So this can't be the copycat cell. So these are all part of the same region, interestingly enough. So this is 2 away. This is 1 away. This is 1 error boundary. So these are all part of the same region here for those 4. So no boundary there. Interesting. We have to have a boundary either here or here. It could be either one. Value of copycat cannot be 2. Could be 1. Could be 1, could not be 2, 3, or 4, or 5. So it could be 1, 6, 7, 8, or 9 for the copycat value. This is value 1. No 2. No... Well... You could have a 3 there. Here... 2 or 3, 1 or 2. One has to be in either 3 or 4 as a value. So, one of these is 1 as a value, and this is 1 as a value. So the only copycats in this column are one of these 2 cells or here. That eliminates copycats in the rest of the column. Interesting. Copycats in value in row 7 could be 1, 2, 3. Value 6, 8, and 9. So these are all values, unless they are in blue specifically. Circle. We know this cannot be 3, because that would be 3 away from the copycat cell in the region. So this is 4 through 9. We know one of these has a value of 1. So this... Ah, this is a copycat cell. It cannot be part of either of these. This is one region here which has a copycat cell. So this has to necessarily go out this way. So this is necessarily not a region border. These are not part of the same region. So these two must be part of the same region. Otherwise, because this can't extend, it cannot orthogonally connect out to another region. So that's not a region border. So we have a region border here or here. And then we have one more going here. Interesting. So this can't be, well, we can't have a 1 there anyways because of 1 in the column. What else? There's at least one boundary here. Hmm. These are different regions. That satisfies that numbered rooms copycat. This is 1, so this has to be a separate region there. Right, because for numbered rooms clue, the first n cells, which is 1, belong to the same region. This is 3 or 4. These are different regions. So this is all belongs to the same region, at least. So there's no boundary here, there's no boundary here. So there must be boundary here, which means this is part of the 1 region here. So there's no boundary here. And that's from the numbered rooms clues. And then we have a boundary, right? If we try to have 4, does that work? Then we have no boundary here, then you'd have to have boundary there. You could have 3 boundaries there. 1, 2, 3. This is 4. So that could work. Or it could be 3, then you have boundary there. You'd have one more between that. That's also possible. Okay. Interesting. This can never be 9. Circles with a paw print in them. If you have 9, it's going to be a 3 by 3 box as the region surrounding it. 8 is going to have 8 of those cells with 1 extended, so it's not going to be ever 8 away. 7 has to have 7 in the same 3x3 box and could extend, so it's 1, 2, 3, 4 away at most. So 7 doesn't work. 6, I think, has the same problem. We have 6 in the 3x3 surrounding area. That's 1, 2 away, 3, 4, 5 away at most. So then this must be 2 through 5 there. So this can't be 6 for the same reasoning, right? If that's 6, we're going to have 1, 2, 3, 4. You have 6 here. This is 2 away at most here. 3, 4, 5 away at most for the region. So this cannot be 6 there. So circle with a paw print can never be greater than 5. You could have 5 away, so that's fine. For the paw print next to the circle, in the circle, I should say. And obviously 2 kind of works. Oh, interesting. These 2 cells obviously are in different regions. Because if they're in the same... Oh, that's not true. That is not true. Because they measure different areas. Never mind. That's not a given. Okay. What else do we know? Values here for the copycats are 3 through 9. No 1 here, no 2 here, so this is 3 through 9 as a digit, which is the same. Oh, these are digits also. But we don't know if they're digits or not. So Okay. So this cannot be 8 here. Because if this is 8, therefore this would say this does not have... The nth plus 1th cell is in a different region than the nth cell, but we know these have to have no boundary between them. So this is not 8. Could be 1 here. So we have 1, 2, 3, 4, 5 cells already in this region. Oh. Wait. Hold up. Whichever one is here is part of this region, which is no is part of that region, which means this cannot be a copycat. This can't be a copycat because we already have a copycat in the region. So the copycat in column 4 has to be this cell. So this is copying a 1. So we don't know what the digit is. So this is copying a 1, which means there's no copycat in the row and column left. And we have a guaranteed 1 in one of those 2 cells. Interesting. So that's copying the one that's orthogonally adjacent. So this is a copycat. Does that help us very much? Not particularly. So if this were a copycat, it would copy a 3 or a 4. So we know these are the same region. At least. Wait, hold up. It can't be 1 here. And if you're copycatting, it could be... So we know... Sorry, these two are part of the same region. We could have a 2 here. We don't know. But if it is copycatting, it's copycatting a 3 or 4. This is copycatting what? Diagonally from... Here is this cell. Hmm. Okay. This can't be 6 anymore. So the copycat cell in row 3 has to be 1, 7, or 9. No copycat there, no copycat there. Okay. 7's already tailor-made here. You could have a 3 copycatting or being there, right? Oh, this can't be a copycat, so 4 cannot be here. So that means the value of the copycat cannot be 3 anymore. Can't be 4. So this is not copycat. So this is guaranteed to be 1, 2, or 3 as a digit. This cannot be 9 because the value of the circle... Yeah, the value of the circle is 2, 3, or 4. Can't be 2, can't be 1, so this has to be 3 through 9. No 9. 3 through 8. Where is 1 possible now? In row 1. Can't be here because of 1 in the column. These cannot be 1 because of matching... Oh, this could be 1 here. Shoot. Okay, so this could be 1. Never mind. Can't be 2 because of 2 in the row. But this could be 1. So 1 is either here or here. Never mind. Right. We see one of these 2 as a boundary, and one of these 3 cells, or 3 boundaries is a boundary. 3 edges is a boundary. See 2 boundaries here. This is not 3 or 4 away from here. So these have to be separate regions. And this is 3 or 4 away from its copycat cell. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Oh, this is 1 away from its copycat cell. Can't be here, can't be here. It has to be here. Okay. That eliminates copycat cells in the rest of the row, rest of the column. So this is a copycat cell, which means it's copying 3 or 4. So we do know then this can't be a boundary. This is in the same region, so this can't be a boundary. We cannot have... Well, we could have a boundary there. Never mind. So these are all part of the same region. This has value 3 or 4, but we don't know what. Well, we know one of these two is a boundary, at least. Maybe both. This could be part of this region. That's 3 away. Where are the other ones? So 3 could go that way. 3 could go that way. 4 could go here. 4 could go here. 1, 2, you can't go 3 that way. You could go 4 that way. Okay. Not too helpful, but anyways. Interesting. Okay, so this portion here, we necessarily only have one boundary between one of these two. So this necessarily has to go either that way or that way. Huh. Interesting. Does that tell us anything? I don't really know. If it goes this way, obviously this cannot be Copycat. Because we already have a Copycat here. If it goes this way, though, that's perfectly fine. This can't be 8 or 9 for the Copycat, so the value is 5, 6, or 7. Cannot be 6 anymore. Could be 8 or 9 for the Copycat value. No 6 here. So this cannot be 6 because of Copycat. So can't be Copycat cell. Cannot be 8 and 9. Interesting. Let's see. Interesting. Value-wise, 1 cannot be in 5, 6, or 7. So we could have 1, 2, 3, 4, 8, or 9, technically. Very unlikely, but possible. Copycat value can be 1, 2, 7, or 9 here. But these are just values. 7. We have to have a boundary here. Because it's at least 1. It cannot be a 1 in value. If this were 1 in value, the problem is that you would necessarily have to have a boundary there. But that would be saying that in the first cell, you have a value of 7, which you can't obviously have. That means it must be the first 2, right? It has to be in the second cell. The first 2 cells are in the same region. So then this is 2. So this has to have a value of 2. And this has to have a value of 1. And it is a 1. So we see that then this is not valid, or not boundary. So that's 7. So this is value 2. This is value 7. What about this? We don't have anything restrictive there. 2, we don't really have anything. This is a value of 2. It could be a 2 by itself, but we don't know. Okay. Okay. We do know that diagonally opposite, or whatever it is, rotationally opposite of 2 and 7 have to be here. So that does eliminate 2 and 7 in the rest of the row, aside from the rotational opposite. We have 1, 2, 3, 4, 5 cells in the region. Can this ever be 5? So we have 1, 2, 3. If we try to make that 5, that's 1, 2, 3, 4, 5, 6, 7, 8. That does work. Okay. Obviously, 2, it'd have to go that way to go around, because it can't go that way because it'd have to go that way. 3, it could be just part of this region. That's possible. Or it could be separate region. 4 could be part of this region. Yeah, it's too broad. We have a 7 somewhere here. It cannot be in 6 or 7. So 1, 2, 3, 4, 5. 8, 9. It can't be 1. Because then it would say that 7, the value of that cell would be 1, but then saying that the first cell has to have a value of 7. So it's kind of similar to a constraint that you normally have in numbered rooms clues. This is a value of 1, so it cannot be 6. Cannot be 5. So we have 1, 2, 3, 4, 7, 8, and 9 as possibilities. Technically. Actually, we don't. If these are all part of the same region, these would have to be part of the same region. So, because these are part of the same region. So this is actually just 1 through 4 here, interestingly enough. Can it actually be 4? If we have 4 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So this cannot be 4. We have a definite boundary between, it's 1, 2, or 3 then. Can't be 1, because the value of, if you have a value of 1, the value of 1 would be that. Can't be 2, because if you have 2, that value of 2 would be in the first cell, because this is not a copycat. So this must be 3 then. So this is 3, that's 2. That's interesting. So this can't be 2 there. So the first 3 cells here are in the same region. And we have a boundary there. Interesting. Huh. Remaining digits of row 8. Let's do all of them. 1, 4, 5, 6, 7, 8, 9. No 1 here. No. Oh, this is 2 away from the copycat cell, so this must be here. So this is a copycat cell, and these are in the same region. This can't be 1, because we have a guaranteed 1 in one of these 2 cells. That's fine. 2. This is copycat. These are the 1 away, so this has to be a 1 here. That eliminates a 1 in the rest of the row, because this is a paw print away from the copycat. 1 cell away from the copycat. You could technically have 7 borders here. Yeah. What is that copying? That is 4 in value, right? 1, 2, 3 up, left 1, 1, 2, 3 down, right 1. So that's 4 in value. So this is 4 in value, which means this sees 4 boundaries here, which means this must see 1 less. So this is 3 boundaries, 2, that's 1 in value. So this must be 4 in value here. It sees 1, 2. So we see 1, 2 here. This cannot be 3 or 4, because this is not a copycat. Could be 4. Can't be 3, though. No 1, 2, or 3. This is a copycat cell, so no copycat cells there, or there, or there. Wait, this can't be 1, 2, or 3. It's 8 or 9. Oh. The copycat cell is an 8. Right. So that's 8, which means there's a boundary between these 2, because n and n plus 1 must have a boundary. This is 4 in value, so we can remove that now for actual, because it's copying that cell. This is 8, that's fine. That eliminates 8 in the rest of the column. 7, the 7th cell does not have a 1 in value, so this is not 7. Cannot have 8th in value for the 1 digit, because this can't be 1. Oh, this couldn't have been one anyways, so that's fine. Um, hmm. Remaining digits. Hmm. No 1, 2, or 7. 3, 4, 5, 6 cannot be 9 because these are two separate regions. No 7, it could be 8, technically. Two are the same region. These are the same region. We have 4 boundaries, so 1 boundary here. So that means these are not separate regions because this is a separate region than this. So the boundary between this, since there's only one boundary between these cells, has to be between this region and this region, which means this is not a boundary, and this is 3 away from the copycat cell. So these are the same region. This has 3 cells that are part of its region, and we have all 3 accounted for. So this is all 3. Interesting. There has to be a boundary here. So this is not going to be part of any region going that way. So this has to be part of that region. So this is not a boundary because we have a boundary here. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 at most, 8, 9. So we know there are no boundaries between these two. Because this is the maximum we can have going that way. We can't go this way. Oh, wait, whoops. This doesn't have to be bound. This is definitely boundary. This does not, though. We could extend that. Ooh. Okay, never mind. We do know that this does have to be portion of that, though. This is unfortunately not blocked yet. It's one of these two, right? So this is either part of this region or it's part of this region. Hmm. Hmm. So this is 2. Hmm. That means, well, we don't know if this is a boundary. This could have a boundary there. Huh. Um. Hmm. We have a copycat in one of those 4 cells. We don't know which. This cannot be 7. It's 3, 4, 5. This can't be 7 anymore, so it's 5 or 6 with a copycat. Hmm. So this is actually a 7. 2, 3. This can't be 1, 2, or 3, so we have 4 through 9 here. This is all either going to be part of the 1, 2, 3 there, or it's going to be part of the 1 and 3 there. So this cannot have 1 or 3. So we have 2, 4, 5, 6, 7, 8, 9. But this can't be 2 or 2 because of 2 in the column. Columns, I should say. No 7 here because of 7 in the column. These are separate regions, so this has to be a boundary that way. Therefore, this has to extend there. Hmm. No 4s here because of 4 in the column. We have to have a 2 somewhere. Okay, so where is this going to get a 2? There has to be a 2 somewhere in... Well, I guess this could be 2, technically. Yeah. Never mind. I was thinking there. Well, okay. There has to be a 2 in this region. This is not part of this region because there's a boundary there. Because this... How do we know there's a boundary there? Oh, because we have 3 cells here in this 3x3 area for the circle. So there definitely is a boundary there. So these are not the same region. But we could go this way. But this region already has a 1, so cannot go past this. And therefore, where is it going to get the 2? It can't get it from anywhere here. So the 2 in... Oh, interesting. The 2 for this region has to be... We could have 1, 2, 3... Can we ever get past this? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we can't get over here. So the 2 in this lower central region is guaranteed to be one of these digits, which means this cannot be 2 here. It's either 3 or 4. Okay. You could have 1, 3, 4, 5, 6 as a 1. This cannot be 1 as a value. This can't be 1 as a value. Because if it's trying to copycat, it copycats whatever digits here, which can't be 1. And same with this, right? If this is not a copycat, it can't be 1. If it's trying to copycat, it copycats a non-1. And therefore, this can't be 1 in value. So this cannot be 5. One of these is a 2 for this region, because we need a 2 for that region. These are separate regions. We have one boundary here, one boundary here. Huh. Well, this could be a boundary here. What does that mean? Anyways, this can't be 1. It cannot be 4. Because it can't be a copycat cell. And this is guaranteed to be 1 as a non-copycat cell also. This is 4. So we see 2, 3, or 5 boundaries here. And it's also 2, 3, or 5 away from its copycat cell. Can it ever be 5 away? 2, 3, 1, 2, 3, 4, 5. Yeah, technically. Okay. One has to be in a copycat cell somewhere. What else do we have? Oh, this is... We have a bound... These are all in the same region. Ah, so this is copycatting a 3 in value. So this is 3. So we have boundary here. This can't be part of that region because we already have a 3 in that region. So no 3 here, no 3 here, no 3 here. And 3 away must be a 1. 3 away here must be a 5. So this is 5, no 5 there. 3 is there. There's a boundary here. So we have one more boundary in one of these edges. So no one here. This could be still 1 as the copycat. What can this copycat? That would be 8, right? So 3 down from the corner, which is 3 up from the corner. This cannot be the copycat. So it's either 7 or 9 here. Okay. We do not have a bound. Well, it could be 9, right? It could be 7 or it could be 9. This is 3. We have boundary here. Therefore, there's no boundary here. So we have 1, 2, 3, 4, 5, 6 cells in that region. 7 or 9 is the copycat. This can't be the copycat because this can no longer be 3. So the copycat is at 9 here, which means this is copycat here. This is 5 away from that cell, interestingly enough. No more copycats here. So where can 1 be? 1 cannot be here. So 1 could be at 1, 4, and 6. That's still possible. Copycats in 4, 5. Copycats in 5 or 6. This cannot be 5, though, anymore. If we have boundary, 1, 2, 3, 4, 5 boundaries, this would be blocked from being possible. So this is 2 or 3, and it can't. This is 3 guaranteed, so this must be 2. So this is 2 away from copycat. Well, these are not 2 away. This is not 2 away. There's no other copycat that's 2 away. It has to be here. So that's copycat, which is 2 away. And it has to be able to go this way. So there must be no boundaries between them, because the steps-wise, it would be 1, 2. Oh, wait, this could be it. Never mind. It could be 1, 2. Never mind. Okay. That's 2 away. We see 2 boundaries here. That's the 2 boundaries there. We don't know about those 2 boundaries. This is going to have to go down somewhere. But we don't know where. Okay. So one of these 2 is a copycat. We don't know which. Well, if this is a copycat, this can't be copycat. If this is a copycat, this can't be copycat. So this can't be copycat. Which means in column 3, the copycat is here. So this is 4. That means this can't be 4 here. So we cannot have a 1 here. Because if this is 1, the value of 1 would not be in 1 or 6. Because there's no, this is the copycat for that column. No copycat here. Therefore, this is a 7. That eliminates 7 in the rest of the row. And there is a boundary between 7 and 8th cells. Okay. No more 4 here. No 4 here. This cannot be 1 because of 1 in the column. So where's 1 in row 1? It does have to be here. So that's 1, which means this is a boundary, right? Because first and the second cell has a boundary. We have a boundary here. So this must be the 1 also in value. and this is 2. So this is 2, which makes that 3. Interesting. So we have one boundary here. This must go this way. But it cannot... Can it be part of... It cannot be part of this. Could be part of this, though. So there's no boundary here. This is necessarily part of this cell here. Because this cannot be part of this region. So we have 5 through 9 left in row 1. This can't be part of this region because this already has a 1 in its region. Can't be part of this region. So this has to exit. It cannot go here because then this is part of its region and it blocks that from having a region. So this has to go be part of this region. And therefore it has to go something like this or something like this. So these are part of the same region. There's not enough space here for all of this region. Therefore, these are all part of the same region. So no boundary here. We have to have a boundary between this region and this region. So this cannot be a region here, or boundary there. And this has to orthogonally connect out to all 9 cells. So this has to be a boundary, no boundary there. Okay. Between the 4th and the 5th cell is a boundary. So this is a boundary. So this has to go that way. Because you don't have enough cells for a 9-cell region. 1, 2, 3, 4, 5, 6, 7, 8. And then it can go here or it could go there. We don't know. But that's 8 at most that way. 1, 2, 3, 4, 5, 6, 7, 8. But it can't go here. 1, 2, 3, 4, 5, 6, 7, 8, 9 would mean this is 3 cells in the region. Oh, it could be 4. It could actually be 4. Never mind. Okay. Can this ever be a 3 in value? The answer is no. So we're guaranteed this is, if this is a copycat, it's 2. It can't be a 1 because if this were, okay, so this 3 eliminates 3 here. If this were copycat, it's copying a 2. Which means these 2 would be in the same region. It cannot be 1 by itself because that's saying 3 has to be in the value of 3 has to be in the first position, which is obviously not going to be the case if that's 1. So we are guaranteed there is no boundary there. So this has to be boundary there. We do not have enough space here except to extend here. So this has to be 9 here. Cells, because there's no other place for this to go. So we know this is boundary. There we go. Boundary, boundary. So we know this is 2 away. That's 1 away. This sees boundary 4, 1, 2, 3, and then 1 more here. This is 2, and then it sees boundary. So this must be value of 2. And it cannot be 2 because of 2 in the row. So that means it must see, must be a copycat. So this is a copycat, which means this is not a copycat here. No copycat here. That means copycat here. So this is 5. That eliminates 5 in the rest of the row. 5 in the rest of the column. And after 5 is the 5th and the 6th cell are different regions. So this has to go this way. So this is separate. These have to be no boundaries here. 3 eliminates 3 in the rest of the row here. 2 again could be, okay, so 1, 2, 3, 4, 5, 6, 7, guaranteed. Then it could go 8 and 9. It cannot go 8 and 9 there, but it could go 8 and 9 there. No, it can't go 8 and 9 there. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 would not work. Oh, wait, this could be 2. Well, not anymore because that's 2. Okay, so it could have been 2, actually. But because of the way that No, this couldn't have been 1 in value, so that didn't affect that at all. Okay, so this cannot be 2. Oh, but there had to be a boundary anyways. So 1, 2, 3, 4, 5, 6, 7. So no boundaries here and here. Could go up here. Oh. Well, either way, it's going to be... This is going to be a boundary because this can't... The ones can't be in the same region. This sees... Okay, this sees 3 boundaries. So 1, 2, 3. We have 5 here. So 1's here, that's 4. And then 1 more between these 2. Okay. 3 boundaries. We have 1 there. This could be 4 if it goes something like that. And then like that. This cannot be 9, obviously. Remaining digits of... Okay, where is the 1 in a copycat cell? We have 1, 2, 3, 4, 5, 6, 7, 8 ones. So we know where the 9th one has to be. It has to be there. And is the copycat. 2 eliminates 2 in the rest of the column. No 7 or 9 in the rest of the column. So it's 4, 5, 6, 8 in column 9. So we've got all the ones. These are separate regions. Remaining digits of row 3. We have 5, 6, 7, 8. Oops. I clicked on that. 5, 6, 7, 8. No 5 or 8 here because of 5 or 8 in the row. In row 7, we have 4, 6, 7, 9 as possibilities. No 4 here because of 4 in the column. No 7 here because of 7 in the column. Remaining digits of this lower right hand region. This can't be 4. It's 4 through 9. We have 2, 4, 6, 7, 8, and 9 for the cells in the lower central region. This is copycatting a 1. This is copycatting a 3. This is copycatting a 4. This is copycatting 2. Oh, this has to be a 3. Because the value is 3. These are not part of the same region. Because there's an extra 7. So this is a boundary. This has to go out somewhere, so this cannot be boundary. There's no way this is seeing 8. This has to go out that way. So there's no way this is seeing, well, it's possible, I guess. 7 and 9. This sees 4 or 5 cells. Huh. if this 4 or 5 cells were different than this region here, the problem with that is how would this form a full... This would have to exit out and would block this from being a fully formed region. Right? If this is 4 and 5, it has to exit. It goes that way. So this must be part of this region here. So we necessarily cannot have... So this... Can this all be one region here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that could all be the same region. Okay. No 1, 2, or 3 here. Remaining digits in column 4 are 4 through 9. This can't be 2 because of 2 in the column. Seven can be 2, can be 3 away, cannot be 8 or 9. So this is 2 or 3 here. Interesting. One boundary there. Okay. There's a lot of stuff going on here. 5 eliminates 5 here. Remaining digits in column 6 are 2, 4, 6, 7, 8, and 9. No 2 or 7 here. No 2 here. No 4 here because of 4 in the row. No 4 here. Remaining digits of row 6 are 5 through 9. Where is the 2 in column 6? It has to be here. So that's 2, which eliminates 2 here. That's 3 and 4. So no 2 here. No more 4 remaining in this region, in this row. So 3 cannot be part of this region because we already have a region. And in fact, all of these are in the same region because all 4 of them are in the same region. So we have a boundary here. This must go up here. So this is a separate region than this. So we have boundary there. We cannot go to the 1. Wait, that's gonna break. No! That's gonna break. 1, 2, 3, 4, 5, 6, 7, 8. Frig! Frig, 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 frig. Unless this is 4 and this is 3. No, it can't be 4 because of 4 in the column. No! No, no, no! Shoot, I hate this. Basically, yeah, again, this is like, I think I've talked about this multiple times, but when you've like done so much, but you don't know where you messed up, it's just like, this is such a pain. Shoot, this has to extend out there. And it has to go there because this has to... Shoot, that's annoying. Four cells all in the same region. Yeah, it was working so well, and then we have this problem. Oh, wait, wait, wait. Oh, okay, I think I see it. Never mind. I do see it, then. How did I make this assumption that all of these were part of this? So you can't get to the 1, but you can go here. So I don't know why I didn't see that. Anyways, okay. That's the error. Okay, so we gotta go back before then. to see where the problem is then. That's going to be a long way. Oh boy. That's going to be a long way. Oh boy. Okay. Well, let's try to continue. Okay, so that was... Right. It was that. Well, we don't know that. We know this and that. So we have 1, 2, 3, 4, 5, 6, 7. It could be 8, 9, but it could extend here. And we now know that it does have to extend here because of the way that this worked. So this has to be 2. Cannot be 2 because of 2 in the row. So this must be cannot be a natural 2. So this has to be copycat, which means this is not copycat, which means that's not copycat. So this is copycat here, which is 5 away. And there must be a border between the 5th and 6th cell. 3 must be the second digit, so this is 3. And we have 8 ones. So the last one has to be in a certain position, which is there. No 2 here. No 7, 9 here. No 7, 9 here. So we know this is boundary. What did we want? Oh yeah, no boundary here, no boundary, no boundary. But we don't know about these. So but this is still 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're guaranteed at least these are in the same region. No 2 here. No 2 here. So we could have 2 there. That is still possible. Actually, is it? We need a 2 in a copycat cell. 2 cannot be here, because of 2's in the rows and columns. No 2 there, 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 so 2 in the copycat column has to be there. This is not 2. Because of this rule set saying that there has to be a border here, this can't be 8, 9, or 5, so this must be 3 that way, which makes that 4. So the third digit in the third cell must have a value of 7, so that's 7. And then they must be all in the same region. We already knew that, though. So we have the same region. These are all 4 in the same region. So we cannot have 4 or 7 in that region. There has to be a boundary in one of these. So 1 could be part of this, or 8 could be part of this. We don't know. And these are different regions. So we need boundary there. So here, we are stuck in this certain way. You cannot go this way, because then this would be part of all this region, which is obviously not the case. We have 4, 6, no 4 here, so it's 6, 7, 8, and 9 there. No more 4 remaining here. So this can be at most 1, 2, 3, 4, 5, 6, 7, 8 cells in the region. We cannot go that way because it's part of this other region there. We cannot have a 1 as a duplicate. We cannot go here because these are separate boundaries here. So we are guaranteed we have to go that way. So this is not boundary, so this is boundary here. We have at most 1, 2, 3, 4, 5, 6, 7, 8, 9 cells in the region. And we could go 1 more. We don't know. Okay. Remaining digits in row 7, we have 4, 6, and 9. Remaining, no more 9 here. So we have a guaranteed 9 in the bottom right region there. Remaining digits in row 6 are 5 through 9. No 5 here because of 5 in the column. No 5 or 7 here because of 5 or 7 in the column. No 5 here because of 5 in the column. No 8 here because of 8 in the column. Okay. So we don't know if we go up here. So if we go up here, there's going to be a boundary between these two. If we stop here, then this is not going to be a boundary here. Okay. So this cannot be part of this region here, because if this were part of that region, you'd have a boundary here and then a boundary here, and that would be 2 boundaries. So this is definitely part of there, that cell, that region. So this is part, this has no boundary there. There's definitely a boundary between one of these two. So the 7 either goes to the 8 and then goes up, or it goes to the 1 and then goes up. That is both, they're both possible. This is 2 away from its copycat. So that it has to go, this has to go that way. So this connects to these two. Because otherwise it's not going to be able to get 2 away from its copycat cell. Can we go, so 1, 2, 3, 4, 5, 6. So can we not go this way? So can we go, this is part of that? Possibly. We don't really know. Oh, boundaries. Remaining digits too. So boundary 3 eliminates 3 here. We have 5, 6, 7, 8 remaining in row 3. No 5 here, no 8 here because of digits in the columns. These are all part of the same region because this must extend out somewhere. This is 7 though, and 7, so then we have boundary there. This must extend out here. This must extend out there. 3 boundaries. So we have 1, 2, 3 that it sees. This sees 1. This must see another one. So this is not going to be the same region as this. Remaining digits in column 4, we have 4 through 9. No 7 here, no 7 here because of 7's in the row. We have a guaranteed 9 here, so this cannot have 9. Again, can this be not part of this region here? If this is not part of that region, it's part of this region, it has to exit out somewhere, and then this will block this from ever being a full region. So this has to be part of this region here. So this is 4 or 5 going this way. It could just be all of these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is definitely part of this. You could even do 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7, well, we don't know yet. This is 4, 5, 6, 8, 9 as possibilities. No 4 here because of 4 in the column. Where is 3 for a copycat cell? None of these work, so it has to be here. And that is that even 8 threes? No. We have 1, 2, 3, 4, 5, 6, 7, 8 threes now. So we know where the last 3 has to be. It has to be there. Aha. So this cannot go this way because we know this is a separate region. And if we try to go this way, the problem is that it gets blocked by the 3 and it gets blocked by this cell, which has to be a separate region. And then that's too small. And we need, yeah, it gets blocked from this access to this 2 by the 3 here. So we know this must go this way. So we have, this is not boundary. This is not boundary because we need the 2, and we need to access 2 away from the copycat cell. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. So we have region there, region here, region here, region here, and region here. So that's done. That means all of this is a region so far. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2 away from the copycat, which is fine. Oh boy, this is going to be hairy to like double check all these things, but okay. Okay. So regions we have done, we don't need these. So this is 9 cells here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then that's done as a region, which means this is done as a region. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. Okay. And we have 1, 2, 3, 4, 5 borders. So this cannot be a region border. Let's remove all of these. We have all of these regions done. This one we don't know. This has to go, this is part of this region because it can't be part of any other region. So we have these. So 1, 2, 3, 4, 5, 6, 7. Guaranteed. Okay, we have 5, 6, 7, 9 left in column 1. Column 2, we have 2, 6, 8, 9 left. And this can't be 2 because of 2 in the row, so it's 6, 8, 9 as a triplet, which eliminates 6, 8, 9 in the rest of the column. So no 6, 8, 9 there. It's 2. This cannot have a 5 because it's guaranteed to have a 5 in this region. Same with this. This can't be 5. This can't be 8 because it's not going to have 8 cells in its region. Because these 3 are not part of it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 could be there. Okay, so can this expand? Okay. This can never be 6 because it's going to be too large as a region. Also, it can't be 4. Oh. This cannot be straight 2 away from here. Because if this is straight 2 away, the problem is it's stepwise not going to be 4. It's not going to be 4 or 5 away from the copycat cell. So this cannot be part of this region. So we know this is boundary. So you cannot close this off here. So then this has to have a boundary there. Well, technically, okay, so this cannot be 4 or 5 unless it includes this now. And it has to be 4. 1, 2, 3, 4 away from the copycat. And so this has 4 cells that are part of its region. So it has to be this way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's done as a region. So boundaries, no boundaries there. So that's done. So that eliminates 7 and 9 in the rest of this upper right-hand region. Okay. This has 1, 2, 3, 4, 5, 6. This is 4 away. This is 1 away. This is 2 away. That's good. No more 5s in row 1. So this becomes a 6-8 pair, which eliminates 6, 8, and 8 in the rest of the region. So this can't be 6 or 8, it's 5. This can't be 6 or 8, it's 7 and 9. So there's no more 7 or 9 in this upper central region. So this can't be 7 or 9. No more 4 or 5 here because of 4 or 5 in the row. No 5 here because of 5 in the row. Remaining digits in row 2 are 6, 7, 8, 9. No 7 here because of 7 in the column. Same with no 7 there. 4 eliminates 4 here, so that's 6. So this cannot be 6 here. So this is a 4-5 pair, which eliminates 4 and 5 in the rest of the row. So no 4, no 5 there. How many steps away is this? 1, 2, 3, 4 could go there. But the problem is it would go through a 3, which already is in that region, so that's not possible. 1, 2, 3, 4, 5, 6, 7 is too far. So this must be part of this region here. This is 1, 2, 3, 4 steps away. So this is 4, that's 5. No more 5 here, no more 5 here. We have a 6, 8, 9 triplet in column 8, which eliminates 6, 8, and 9 in the rest of the column. So this must be 4. We cannot go here. That's boundary. That's a different region. We can't go here because it's a 3. That's boundary. We have 1, 2, 3, 4, 5, 6, 7. We cannot go here because then that would block this cell from having a region. So it has to be region, region there. So then that's the boundary there. This 6 eliminates 6 here, so it's 8 and 9. 6 eliminates 6 here, so it's 8 and 6. No 6 or 8 here, it's 5. That eliminates 5 in the rest of the region and the row. Well, we already knew that. That can't be 5. No 8 or 9 here. This is 6. That eliminates 6 in the rest of the region. So this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the row. This can't be 4 or 6. It's 9. 6 eliminates 6 here. Wait, we have... This is not 6. This is 9. No 6 here. No 6 or 9 here. We have a 7, 8 pair in column 7, which eliminates 7 and 8 in the rest of the column. So this can't be 7 or 8. It's 5. No 5 here. No 8 here. It's 6 or 7. The 7, 9 pair is part of that region. Well, and this is only part of this pair. So we have 1, 2, 3, 4, 5, 6, 7, 8. And we need access to a 4. So it must access that. So that's done as a region. This can't be 7 because of the 7, 9 pair in the region. So this is 6, that's 8. No 8 or 9 here. No 9 here. 6 eliminates 6 here, so that's 7. That eliminates 7 there, so it's 6. No 6 there in the region, so it's 9. That's 5. No 5 or 6 here, that's 9. No more 9 here. This is 6, 8 as a pair, which eliminates 6 and 8 in the rest of the region. So that leaves that as a 5. No 4 or 5 here. 6, 7, 8, 9. 7, 8. No 6 here. Where is this? You have a 7, 8, 9 triplet in this lower central region, which eliminates 7, 8, 9 in the rest of the region. So this can't be 7, 8, and 9. It's 6. This can't be 7, 8, and 9. Or 6, it's 4. So no 4 here. 6 eliminates 6 here, so it's 8 and 6. 7 in the copycat cell eliminates 7, so this is 9 and 7. That means no more 9 here, no more 9 here. So this is, okay, so we have, this is full as a region. This is done as a region. This is done as a region. We have these 4. This cannot be 9, it cannot be 8, because these are obviously not part of its region. 6 eliminates 6 here, so it's 7. No 6 here, or 7 here, because of 6 or 7 in the column. 9 eliminates 9 in the copycat, so this is 8. That leaves this as a 5 for the copycat. So no more 5s, no 5s here, no 8 here. We have a 6-9 pair in column 4, which eliminates 6 and 9 in the rest of the column. So no 6 there, it's 4, no 6 or 9 or 8 there, so it's 7. Which makes this 8, which makes that 9. No 6 or 8 here, it's 7. And 5 eliminates 5 here, so we have 6, 8 as a pair, 6, 9 as a pair. This region needs access to a 4. It cannot reach this area. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that would be 10. So this must be part of that region. This must have 4 cells in that region. So this can only connect going this way. So then these are boundaries. And this is done as a region, and that's done as a region. Okay. 8 eliminates 8 here, so that's 6 and 8. 6 eliminates 6 here, so it's 9 and 6. 8 eliminates 8 here, so it's 7 and 8. And let's double check. Oh boy, this is going to be a lot of double checking here. Okay, let's start with copycat cells. Each one cell in each row, column, and region. Region here, this region there, this region there, region there, region there, region there, region there, region there, region there. One in each row. 4, 5, 6, 7, 8, 9, and one each column. That's correct. And contains a different digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Numbered rooms. Numerical clues outside the grid are numbered rooms clues. The clues indicate the value of the nth cell from the clue from that side of the board, where n is the value of the closest cell. So, 1. And in this puzzle, the first n cells belong to the same region, and if n is less than 9, the cell in position n plus 1 from the clue must belong to a different region. This is value 1, and the value of 1 is in the first cell. So, and therefore, this is a different region, which is valid. Value 1 is in the third, this is value of 3. That's saying 1 is in the third cell, of the value of 1 in the third cell, which it is. And then there's a border there. Value 1, this is value 2, which says that there has to be a value 1 in the second cell, which it is, and then you have to have a boundary in the next cell. Value 2 means that value 7 has to be in the second cell, which it is, and then there must be a border after. This is value 2 because it's copycatting a 2 on the other side, on the rotationally opposite side. And so it's saying the value of 3 has to be in the value of the second cell. And then there it is, and there's a border on the other end. 2. This is a value of 3 here. The 3 says that the value says that 2 has to be a value of the third cell, which it is, and then there's a border after, which it is. And these are all the same region too, I should say. Same region, same region, same region, same region, same region, same region. This is copycatting the value of 3. So that means in the third cell, there must be a value of 5, which there is. And then they must be in the same region, and then this must be a different region, which it is. Value of 1 saying 1 has to be in the first cell, which it is, and then it's the same region, and there's a different region after. Value 3 means that in the third cell there must be a value 7, which there is, and then they must all be in the same region, which they are, and this must be a different region, which it is. So that's numbered rooms. Numbered copycats. Cats outside of the grid indicate the nth cell from the clue is a copycat cell, where n is the value of the closest cell. And if n is less than 9, the cells in the n plus first position must be in a different region, but that doesn't say anything about the number of region borders between the clue and the copycat clue. 5 is value. That's saying the copycat cell is in the 5th cell, which it is, and then these must be different regions. 4 value, saying copycat is in the 4th cell, which it is, and then it must have a border here. This is copycatting value 1, which is saying copycat is in the first cell, which it is, and then there's a border there. This is saying copycat is in cell 9, which it is, and since it's not less than 9, we don't have anything else related to that. This is saying 7 value says copycat cell is in the 7th cell, which it is, and they are different borders. This is 8, which is saying copycat is in the 8th cell, which it is, in which case there is a separate border here. Okay, that's that. Paw prints. Oh boy. And we have to take into account the negative constraint here. Okay. Cells containing paw prints indicate the minimum number of steps along a path required to reach the copycat cell in its own region, traveling or toggling while staying entirely within its region. And all possible paw prints are given for this upper left-hand region. 1 is not, these are 1 away. These are 2 away. This is 3 away, 4 away, 5 away. And none of them match. Okay, so that's good. Here, upper central region, region 2, I guess we can say. 0 away, 1 away, 2 away, 3 away, 4 away, 5 away, 6 away. So none of them are paw prints, which works. But region 3, 0 away, 1 away, which does have a paw print, 2 away, which does have a paw print, 3 away, 4 away, which does have a paw print, 5 away, 6 away. But region 4, 1 away, 2 away, 3 away, 4 away. So that works there. No paw prints. Region, I don't know which one's region 5. This one? Okay. 0, 1 away, 2, 3, 4, 5 away, and that's a 9, so that's not gonna have that. 6 away, and they don't match. Region 6, 1 away, 2 away, 3 away, 4 away here, and 5 away here. So the 4 does have a paw print, so that does work. Region 7, 1 away, 2 away, 3 away, 4 away, 5 away, 6 away, 7 away, and none of them, this one does have the paw print. We already did that. Region 8, 1 away, 2 away, 3 away. Those both have paw prints, and 4 away. And then region 9, 1 away, 2 away, which in both of those have paw prints. This is also 2 away. All of these are 2 away. And then 3 away, none of which have paw prints. So that's satisfied. Circles! Oh boy. Again, negative constraints. Okay. Region 1. This has 3, 3, 5, 4, 5, 4, 5 here, and then 4 here, and then 3 here. The 4 does satisfy the circle. 3, 4, 4, 2, 6, 3, 3, 3, and 2. None of which are set have a circle. 2, 3, 4, 4, 5, 3, 4, which does satisfy that. 3, and 2. 3, 5. Oh, it's all supposed to be values. Ugh. I didn't even double check that. Okay, let's look at the copycat. Ugh. Oh, wait, no, the copycat for paw prints is not going to have a paw print because it's 0 away. Okay. What was this? This is copycatting 1, and that's not going to be 1, it's 4. Okay. This is copycatting 3 left and then down 1, which is 3 right and up 1, 6. That does not satisfy, it's 4. Okay. This is copycatting 7, and that's 4. Okay. Oh boy. Okay. This is 3. This, as long as it doesn't copycat 5, which it isn't, it's 6. It's fine. 5 away here. This is 5. 5 this way. 5 here. Around here is 4. This is 4, and this is 3. So that's satisfied there. Region 5 here. 3. 3. No, this is 4. 3 here. Around this is 4. Around this is 5, and that's a 9 in there. Around this is 5. This is 5. This is 4. This is 5. This is 1 in value, and this sees 3. So this is 2, or 3 here. 3 here. Region 6. This is 2. 4. This sees 4, which it has a circle. This sees 5, which it has a circle. This sees 1, 2, 3, 4, 5, 6. This sees 5. This sees 5. This is copycatting a 2, and it sees 5. And this sees 3. So that's fine there. Region 6. Region 7. This is copycatting a 1. Is that right? No, a 7. A 7. And it's 3 in size. This is 3. This is 5. This is 4. This is 5. This is 1, 2, 3, 4, 5, 6. This is 5. This is 4, and it does have a circle. And this is 4, and it does not have a circle. Okay. Region 8. This sees 3. This sees 3. This sees 4. This sees 4. This is copycatting a 3, and it sees 4. This sees 3 here. This sees 6. This sees 3, and this sees 3, and it does have a circle around it. This has 3, 4, 6. This is copycatting what? A 4. Oh, it is a 4. And it sees 6. This sees 5. This sees 7. This sees 5. Also 5 here, and this sees 4. And there's no circles. So, all the circles are done. And then arrows. Oh my god, this is going to be a pain. C's. 2 cells this way. 2 borders this way, 2 borders this way. Oh, this is such a pain. It's not going to see 5. It sees 2 that way. 1, 2, 3, 4 that way. This sees 1 or 0 in these directions. So 1, 1, 1, 2, 3 that way. 3 sees 1, 1, 1, 2, 3 borders this way. So that's satisfied. This sees 1. This is a value of 1. So it sees 1 border, 1 border. That's satisfied. 7, there's no way it sees 7. 1, 2, 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5. I guess, yeah, we can count how many borders are in each row and column, and that's the most you can have. So 2, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2 in rows. So in rows, we have 5 at most. Columns. 1, 2. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Ugh, okay. In rows, we have 5 at most. In columns, we have 7 at most. Ugh. But it's only 1. 1, 2, 3, 4, 5 in this column. 1, 2, 3, 4, 5 in this column. And 1, 2, and 1, 2. So other than this column, we have 5 at most. So we don't have to check any value that's 6 or above, except for column 5. Great. Okay. Let's just do that for 6 and 7 here in column 5. This sees 1, 2, 3, 4, 5, 6 boundaries there and 1 here. So that's fine. And 6 sees this is too many on each side. 1, 2, 3, 4 there and 1, 2, 3 there. So the 6, so now we just check 1 through 5 values. Okay. 2 sees 2 boundaries there, 1, 2 boundaries there. That satisfies the arrows. This is 8, that's too big. 2, we have 1, 2, 3, that's already too many. 1 this way, 0. 1, 2, 3, 4, too many. 5 sees 1 that way, 1, 2, 3 that way, 1, 2 that way. 1, 2, 3, 4, 5, 6 cells, boundaries, so that doesn't work there. So that's fine. This sees 1 there, 1, 2, 3, 4 there, 1, 2, 3 there, and 1, 2 there. Oh, I didn't even take the negative constraint into account when I had to go around, but anyways. That's interesting, actually. This is copying 6, so that's too many. 9's too many. 4, 1, 2, 3, 4, 5 that direction. 0 that way, 2 that way, so that's satisfied. This copies 6, too big. 4 is 1, 2, 1, 2, 3 that way. 1, 2, 3, 4, and it does have the arrow. This has 3, 1 that way, 1 that way, 2 that way, 1, 2, 3 that way, and it does have the arrow. 2 that way, or 1, I should say 0. This is 2 that way. This is 2 that way and 2 that way. 2 sees 2 that way, it has an arrow. 2 that way has an arrow. 2 that way has an arrow. And 1, 2, 3, 4, 5 that way. This sees 1, 2 that way, 1 that way, 2 that way, 1, 2, 3, 4 that way, so no arrows. 2 sees 1 that way, 1 that way, 1, 2, 3, 4 that way, no arrows. 1 sees 1 that way, 0, 1, 2, 3, 4, 1, 2, 3 that way. This is copying a 7 too large. 6 and 9 are too large. 3 sees 1, 2, 3 cells that way. 2 that way. 1, 2 that way, and 1, 2 that way. 4 sees 1, 2, 3 that way, 1, 2 that way, 1 that way, 1, 2, 3 that way, no arrows. 5 sees 1, 2, 3 that way, 1 that way, 1 that way, and 1 that way. 3 sees 1, 1, 2, 3, 4 that way, 1 south. This is copying the 7 too large. 5 sees 1 left, 2 up, 1, 2, 3 right, 1 down. 4 sees 2 left, 1 up, 2 right, 2 down. Too large. 1 sees 1, 2, 3 left, 1, 2, 3 up, 1 right, and it does have an arrow, and 2 down. 2 sees 1, 2, 3, 4 left, 1 up, and 1 down. Okay. 5 here. 1 up, 1 down, 1, 2, 3, 4 to the right. 2 sees 1, 2 up, and it does have an arrow. 1 left, 1, 2, 3 right, and 1 down. 4 sees 1, 2 left, 1, 2, 3, 4 up, but it does have an arrow. 1, 2 right, 1, 2, 3 down. 3 sees 1, 2, 3, 4 left, 1 up, 1 down, 0 right. This is copying a 2 in value. Sees 1, 2, 3, 4 left, 1 up, 1 down. So that's satisfied 2. 1 sees 1 left, 2 up, and 1 left has the arrow. 1, 2, 3, 4 right, and 1 down, and it does have an arrow. 2 sees 1, 2 left, 1, 2 up, 1, 2, 3 right, and 1 down, and it does have the arrows in the appropriate spots. 3 sees 3 left, which it does have an arrow. 1, 2, 3. 1, 2, 3, 4, 5 up, 1, 2 right, and 1, 2 down. 5 sees 1, 2, 3 left, 1, 2, 3, 4, 5 up, 1, 2 right, and it does have an arrow with that 5, and 0 down. And this 4 is copying a 4. It sees 1, 2, 3, 4 left, and it has an arrow. 1, 2 up, 1 right, 0 down. 5 is copying 1. It has 2 left, 1, 2 up, 1, 2 right, and 1 down with the arrow. 4 has 1, 2, 3 left, 1, 2, 3, 4, 5 up, 1 right, 0 down. 2 has 1, 2, 3, 4 left, 1, 2, 3, 4 up, 0 right, 2, 1 down, I should say. 1 has 1, 2, 3, 4 left, same with that 3. 1 will have 1, 2 up, 0 right, 0 down. 3 has, already again, 4 to the left, 2 up, 0 down. 4 has 1, 2 up, 2 to the right. 3 has 0 to the left, 1, 2, 3, 4 up, 1, 2 to the right. 1 has 1 to the left, 1 to the right, and 7 to the top, which is too much. This is copying 3. 3 has 1 to the left, 1 to the right, and 1, 2, 3, 4, 5 to the top up. And 5 here has 2 to the left and 2 up. And that's satisfied. So this is 9. Whew, that's crazy for all the checking. Some of them I didn't really even use, but because of the negative constraints. But it was just easier following a different path to not try to get that negative constraint solved. But yeah, pretty tough. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.